Okay. All right. So the topic for the day is multicast. A light topic, but there are a lot of things, so it will take the whole class today. So from the syllabus point of view, it's the topic from the Encore's module. Okay, this is the topic. So basically, we need to know what are the different multicast protocol like PIM and IGP version 2 and 3. Okay, so we will discuss complete on multicast today, and in the next class we will cover up the other topics. Okay, so we are left with a small portion of SD-WAN 1.4, a small portion of QoS, a very short topic from 2.3, and so this was covered. Let me highlight them. And 5.5 is what is pending from Encore, and from NRC I guess is just MPLS concepts and the DMVPN concepts and IPv6. So that's the few things which is left out. Okay, so SNMP is covered last weekend. I mean last week. All right, so let's move on. Let's check it out. The topic for the day. So what are the topics that we are gonna discuss today? We are gonna discuss why multicast. Okay, so basically we are gonna compare it with respective to the unicast and broadcast communication mode. We also gonna cover the different components of multicast components. So topics like IGMP, IGMP snooping, okay, uh, PIM. So these are the topics that we will be checking out. We will be then moving forward to multicast protocols like IGMP 2. We have a lab for this. Same way we are gonna do IGMP version 3. We got a lab for this. And we finally have PIM, which is consisting of two important variants. One is called as dense mode and one is called as sparse mode. Okay, so these are few topics that we are gonna discuss today. So first thing first, when we talk about the communication in a network domain, so they can be of three different types. Okay, so it can be unicast, broadcast, or multicast. So since we are almost towards the end of this batch, so you guys should be aware, or you should be familiar what are these three different communication mode. Okay, so when I say unicast, they are one-to-one communication. So if I say R1, router R1, they communicate directly with router 2. So on let's say they are directly connected. So 1.1.1.1 to 1.1.2. Now we call it as unicast. How is the packet header look like? So the source will be 1.1.1.1, destination would be 1.1.1.2. This would be the layer 3 header. Similar way, if a packet is moving in this direction, the packet header would consist of 1.1.1.2 and destination would be 1.1.1. Okay, so this is called as unicast. But in the case of broadcast, destination is not known. Or let's say I have a router here, router is connected to the switch, and switch is connected to multiple hosts, host 1, host 2, and host 3. Now let's say if H1 wants to ping H3, so his Ethernet frame will hit this interface. Switch doesn't know whom to forward or whom to send the uplink. It's gonna broadcast to every interface, every active interface. Okay, apart from the interface where the Ethernet frame was received. So it's gonna forward or it's gonna send to the uplink on this, towards this, and towards this. Now this is called as broadcast. And how does broadcast packet would look like? So your L3 packet header for source would be the IP address of this machine. Okay, and for the destination, since we do not know whom to send, we are just gonna enter 255 255 255 255. It's a broadcast packet. Okay, similar way, the L2 header, the source would be the MAC address of this source device, and the destination is a broadcast packet, so it's gonna be all FFFF 48 bits. This would be the content of a broadcast. Okay, so broadcast is such scenario where we are not sure who is the receiver. We are gonna flood it to everyone. Okay, and this is not a very good solution when we have devices in thousands. Okay, because your broadcast medium will be flooded with lot of acknowledgement, hello packets, right? So basically it will put impact on the CPU cycles. So this is not a good solution. Now what about the third protocol communication method? So the communication method in network domain, we call it as multicast domain. Okay, you might be aware lot of protocols, they work on multicast behavior. For example, OSPF, EIGRP, spanning tree, the CDP neighbors, right? What else? LLDP. So all this L2, L3 protocols, they work on multicast. So how is multicast different than unicast and broadcast? So let's say I have router 1. Okay, router 1 is connected to another router R2, R3, R4. Okay, let's say we connect them all together. Now if it was a unicast, I have to define source and destination. If it is a broadcast, I would let the router decide, or router flood it everyone, but router doesn't flood it, you know that. So basically if it is a switching technology, switches would have broadcasted it. Now, in the case of multicast, let's say I am more specific to a group. So let's say from R1 point of view, who is being configured as OSPF. On the rest of devices, I configure OSPF here, I configure OSPF here, but here I'm making use of EIGMP. Okay. Now what happens in the case of multicast is, as soon as you enable this protocols, they start listening on a special multicast IP. So for example, here they start listening on this multicast IP 224.0.5, 224.0.0.5, whereas in the case of EIGRP it would be a different multicast IP. It will not be .5. Now what happens is, the hello packet or whatever the LSA packet or OSPF packet, if they are being sent, they are being sent to .5. Okay. Now let me tell you how the packet structure would look like. The source would be nothing but the IP address of this. Okay. What would be the destination now? Destination would be the multicast IP that's been listening up. Okay. The destination is not going to be the physical IP of R2 or R3. So that's the behavior of multicast. So wherever the destination is 2240.0.5, multicast is going to send the information. So multicast will send over to this, it will send over to this. But this person who is not listening on .5, so basically the packets will be dropped. So what do you conclude with this? So broadcast, or sorry, I mean the multicast is that type of communication mode where one source is sending to group of receivers, okay, or group of recipient. So basically I had two groups who were listening on 224.0.0.5. So the one source sent the multicast traffic to both of them at a time. If it was a broadcast, it would have been sent to everyone, might be thousands of them. If you have thousands of network devices, in case of multicast, the receivers who are listening on OSPF multicast IP are only gonna consider those packets. The rest will be discarded. Okay, so that's a benefit of multicast. So let's see some practical aspect of using multicast when compared with unicast or broadcast. Okay, so where do we make use of multicast? So we know that we make use of it in the routing protocol. One of the best example I would say is video streaming. Okay, so if you have the VLC player, you can just stream the videos and it will be just be sent. So basically how multicast works is, multicast, there will be a server. Okay, the server will send the multicast traffic to the router. Router must know whom to send this, or who is that host machine who has a rightful recipient application who can read the multicast. Okay, that means there should be some application which can recognize the multicast traffic. So on host, let's say I have my uh, VLC player, okay, which can read the multicast traffic. So now router will send the traffic to H1. If I don't have that application here, there is no point that multicast is sent. So basically, so something like I told you, R1, R2, R3 and R4. If you're sending some packet to this and if it doesn't know what is multicast, so what is a point there, right? So R1 will send, or R1 should know who is the recipient or who is the receiver who is listening on multicast. Okay, so basically let's consider an example of video streaming. So let's say I have a server, a video streaming server, okay, which is connected to, let's say it's connected to a switch here, and switch is connected with two host machine, host 1 and host 2, and this switch then connects to router. Okay, and let's say on the other side of our internet service provider, we are receiving this, and we are connecting this to a switch, and switch is connecting once again to host number 3 and host number 4. Okay, first let's consider for unicast mode of traffic. In the case of unicast mode of traffic, let's say if host 1 and host 2, if they wanna stream something, so basically it will be source to destination or one to one communication. So server will send us packet from the streaming server to host. Server is gonna send the traffic from server to host number 2. Similar way, it's gonna send one more packet towards this. It's also gonna send the fourth traffic to this. It's more like source to destination. Okay, so let's say if one link consumes 6 Mbps, okay, and since we had 4 links, how much is the total bandwidth that's gonna be consumed? Close to 24 Mbps, right? So the more number of people start streaming, this will keep on adding up. Now this is not a I don't say reliable, it's not a good way of utilizing the video streaming. You need unicast when you are transferring some credentials which is in very small kilobytes. You need unicast when you need a reliable, or you want to secure this is a video streaming, and one individual connection is taking like close to 6 Mbps, which will end up with 24 Mbps, and might be if there are 4 more users getting connected, then there will be buffering and there will be a lot of other issues. Okay, now let's say in case of broadcast, if the same thing, if it was a broadcast, let's say on a local side, that is the left hand side, and let's say this is on the right hand side, this is a video streaming server is able to serve the traffic, broadcast traffic to these two, because they are connected to the switch, and switch is gonna do the broadcast in nature. All good so far. But the same broadcast traffic, when it hits the router is not gonna entertain those broadcast traffic. Agree? Because router is meant to be a non-broadcast device. So basically what router is gonna do, router is gonna say, I don't work on broadcast, so I'm not gonna do anything to that traffic, so their traffic is getting dropped exactly here. So there is no way the broadcast packet we can use when we have in between of this cloud ISP or routers. So there will be a lot of discontinuity in this kind of approach. Okay, so whatever on the right side you have those hosts, they are not able to stream. Now let's consider the multicast traffic. Okay, so in the case of multicast traffic, a single copy of the traffic will be sent to the switch. Switch will send the multicast traffic to whichever recipient is listening. Okay, the same copy will also be taken forwarded, because router is aware, or router can work on multicast protocols, so they will forward the traffic to the switch. Switch will send it to the recipient. Now how many copies did we use in the case? We just made use of one copy of multicast. Okay, and it was not been flooded in the enterprise. It was just been sent to only those recipient who are ready to take that, or who are ready to accept those multicast packet. Now let's say if this host disconnects from the network, now the multicast will be not sent to this. Okay, it's just those hosts who needs, if he's out of that group, the multicast will be not sent. What happens in broadcast? even if we don't want, broadcast will be forced to that particular host. The broadcast packet will be sent to that host. But in the case of multicast, he has to be part of that. Then only the router is gonna send the traffic. So it is saving lot of bandwidth, right? So that's why the best or the most important feature of multicast is it's gonna save bandwidth. Okay, so if you see people talking about multicast, it's not that to complicate the network, it's because to save lot of bandwidth. Just a single copy of traffic was being sent to all the users who were listening on that multicast destination IPs. It was easy to send the data. Okay, fine. So let's go to the next topic. And yes, regarding to the previous example which I said, R1 connected to ISP, R2 and so on, right? This was just an example, okay? Just an example to show you in a broader way. But in a real world, multicast is still not being implemented on the ISP side, okay? So companies like Netflix, YouTube, or any video streaming, they still work on unicast. Okay, so the traffic between this router and this router will be unicast. That was just an example to show you where we need multicast. Okay, so let's exclude the internet part, and if we talk from the server point of view, which is connecting to thousands of different hosts, there is where multicast can be used. Okay, so you can take that as also a good example if this conflicts. Okay, so in a internet we have not implemented multicast yet. It's the companies like Netflix and all other things, they are still relying on unicast packet. Okay, now regarding the components, we will see the multicast IP ranges. Okay, we are gonna see the multicast L2 ranges, or I can say the MAC address ranges. So let's first do these two things, and we will go with other things. Okay, other things like the multicast protocol over router. Okay, in the sense, when a file server or a video streaming server is sending the multicast traffic to router, how is router gonna know that this host is a interesting host who is looking for the multicast traffic? Because there could be many other hosts who are not interested to receive that video, right? So router, when a router is taking those multicast traffic from video, router should be aware of the host who is gonna take that, or who the host who had requested the router to communicate between the server and the router. Okay, so we need a protocol for that. So we basically make use of the uh, IGMP protocol, which will be used in the step number 3. In the step number 4 is, once let's say router is aware that this is a host 1 who needs the multicast data, but let's assume that we have a switch in between. Okay, so we cannot connect the 3 hosts directly to router. Instead we connect 3 hosts to the switch. Okay, and then the switch will be connected to router. Now the problem arises on the switch end. You sent all the traffic to the switch, but switch doesn't know what to do with that traffic, right? So you need a protocol now which can inform switch what to do with this traffic. Okay, so multicast protocol between switch and the host. And over here we have a protocol which is called as IGMP snooping. Okay, now what else do we need over here? So once the host are requesting for video streaming on a multicast, the multicast packet is arrived on router is forwarding to the switch, and switch knows which is the host where this has been uh, to be sent. Now the problem is, in case of single router, how if I added up this kind of network design? So I had router 1, router 2, router 3 and router 4. Instead of one single router, which we don't use in enterprise, we go with the secondary backup plan as well. So let's say if the video streaming had sent the multicast packet to R1. Now how is R1 gonna decide whether that multicast should be sent to R2 or R3, right? So there should be a protocol who will do the basic metric calculation and will find the shortest path, right? So this is being done with the help of PIM. Okay, and that PIM is consisting of two more flavors or two more variant. We call it as dense and sparse. Okay, so in short form, these are few things which we are gonna do now. What is a full form of PIM? It's called as protocol independent multicast. Okay, so this whole together, all these 5 steps contributes to the multicast operations. Okay, so if you leave one of them, there will be discontinuity. The multicast packet will not reach from the router or from the video streaming servers towards the host, right? So to achieve everything, we need all this 5 steps. Okay, so let me erase this part. Okay, the first topic, IP range. Okay, IP range of multicast. By INA, internet entity, the online internet entity has declared class D for multicast IP purposes. Okay, so the whole 224 range, 224 to 239 range, the whole block is reserved for multicast, and this block belongs to class D. Okay, now if we talk from the reservation point of view, there are a lot of there are a lot of ranges which has been reserved already. Okay, so what kind of IPs are already been reserved? Okay, so let me write over here. It's 224.0.0.0 to 239.255.255 is the multicast IP range. Okay, what about reservation, right? So what ranges are reserved? So basically 224 dot 0.0 till 2240.0.255, which in short form I can also write it as /24. Okay, so this block is being reserved. This is reserved for your network protocols, in the sense all the protocols that we discuss like OSPF, EIGRP, STP, DTP, CDP, they all work on some multicast IP. So this range, the /24 range, they are being reserved for such things. Okay, These are few things, but if I go on writing, there are a lot of things, like every protocol work on lot multicast, right? So you have DHCP, you have RIP, a lot many things. So just whatever, most of the routing protocols that we discussed so far, they were all consisting of multicast. Okay, so this block is reserved. Now there is one more group of range, multicast range, which is also declared to be reserved. Okay, so 2240.1.0 slash 24, this is also reserved. Okay, and who is gonna use this range? Your NTP, your VMTP, okay, NSS, all your uh, protocols of your PIM, okay, there's mtrace, all the latest technology whichever you may not have heard so far. So these are all the protocols, or the multicast IP that they've been reserved for. Okay, so these two blocks are being reserved. Rest anything, you can just use it. You can just use it, or I can say that you can safely use 239.0.0.0 to 239.255, 255, 255, right? The last block of this, I can say that I can use it for my enterprise purpose. If I have a video streaming, I can configure an IP in this range, which is going to be slash 24. That's going to give me 254 valid host. So I think that's pretty enough in an enterprise to have 254 valid multicast IPs, right? So there are multiple other networks, like subnets, so like 225 you can use it, 226, 227, but to be in a safer zone, or to be uh, not fall into all the calculation, all those things, you can just take one simple block from this range and you can use it in the enterprise. Okay, so this is from the IP address point of view, the first component for multicast. How about the look of multicast IP address? So we all know that IP addresses are divided into 4 octets. Okay, this is called as octet 1, octet 2, octet 3, and octet 4. Each comes with 8 bits. Okay, which makes them 32 bits. If I want to convert them into binary format, then I have to write it in terms of 0, 1, 1, this kind of format, right? Something like this. The same approach holds good for multicast as well. Okay, in the multicast, since we know that this is the broad range of multicast, okay, reserved and non-reserved IPs as well, they follow certain similar identification. So I can say that whenever you convert anything, any IP from this range, you will see the starting binary will be always in this format. Okay, so whenever you see some IP which is in a binary format, while you open up the Wireshark, you can predict that this is a multicast IP because of its first 4 bits. Okay, I'll show you why was it easy for someone to recognize that. So let's go to IP to binary conversion online tools. So if you type the first IP of your multicast range, if you convert it, you see that this is starting from the 1110. Let's go with the last IP of multicast, 239.255.255 and 255. Okay, so this will also give us the similar identical behavior. It changed later on, but the first 4 bits were all same, right? So if you see something starting up from this, you can conclude saying that it's a multicast IP address. Okay, so one way of finding out the multicast IP. Okay, what is the second component here? We are gonna discuss the L2 features or L2 MAC address point of view. Multicast MAC address ranges. Okay. Okay. So in the case of multicast MAC address, so whenever we have the layer 2 protocols, let's say STP, VTP, let's say the DHCP application protocol or HSRP, VRRP, right? So each and every protocol will maintain their own standard or their own reserved MAC addresses. Okay, so there will be a MAC addresses which gets generated the moment you enable this. That is from the switching point of view, because router will recognize the IP address or the multicast IP address. But when a router is forwarding it to the switch, how is switch gonna understand, right? So a corresponding MAC address for each protocol will be generated. So that the switch knows that this is a multicast MAC address for so and so protocol, and it has to send the traffic to so and so recipient. Okay, so that's a concept of MAC address in multicast from a layer 2 point of view, layer 2 protocol point of view. What about the third component here? The third component is the protocol over router. Okay, so let's say I have a video server which is connected to router. Okay, and router is connected to a switch. Switch is connected to host 1, host 2, and host 3. Let's say video server sends those multicast packets to router. How is router gonna know whom to send and where to send? Okay, whom to send, because there are 3 hosts. We never know one is the person who needs it and rest 2 doesn't need it, right? And how to send, what is the best path to reach them? So what we need to do here is we need to enable IGMP protocol, which reads to be Internet Group Management Protocol. Okay, Internet Group Management Protocol. So this protocol consists of three variants: version 1, version 2, and version 3. We are not gonna check version 1 because it's been obsolete in the market IT industry, but yes, V2 and V3 are important. Okay, so this is that routing protocol which will keep a record of the host requirements, or whichever the host is requesting for the traffic. So whenever a multicast traffic is received here, the router should know who is that host where this traffic has to be sent. Okay, or which is the host which has left this multicast group and should not be sent. So that's the IGP protocol, what's gonna take care of it. Now the issue is, let's say router knows that that's h1 host. Okay, so it's gonna send that multicast traffic to switch. But what about switch? How does switch will know whether that's to be sent to h1? Because switch by default will do a broadcast, right? So how are you going to tell switch that don't do a broadcast but go with multicast? So in order to achieve that, we make use of IGMP snooping. Okay, so this protocol will be enabled so that switch know on which interface that this has to be forwarded. Okay, or which interface the multicast traffic should be forwarded so that host 1 receives that data stream, or the video streams. Okay, the last approach or the last issue here would be, if there were multiple paths, if I had R2, something like this. Okay, now the traffic could have gone to this as well as this. There would have been a lot of unnecessary multicast traffic flow, right? So that doesn't happen in multicast, because in multicast, if you have two router, the two routers are gonna go into election mode. Okay, they are going to perform a election, whichever is having a better uh, superior, whichever is superior, and superiority is chosen on basis of lowest IP address. So whichever wins this election is gonna be considered as master, or he will be active. Okay, so the multicast traffic will be now on R1. Let's say this is active, and active will take care of all the in and out traffic flow. Okay, and to achieve this kind of election and all this priority or what kind of negotiation, what we do is we enable PIM, protocol independent multicast, over here, so that that's between routers to know which will be the first point of contact for receiving the traffic and delivering this traffic to the host. Okay, so these are the components. Now there's one more important thing which I would say it, or when I would write it in the sixth point, which is multicast application. Okay, so basically how is host generating those multicast traffic? There should be some application which can generate the multicast traffic, right? So one best example is your VLC player or VLC streaming. So if you have this VLC media player, okay, you can just generate the traffic. So the traffic will hit the switch will go to router will go to streaming server, and the streaming server will send back those traffic in multicast. The router should know which is the host who is requesting that traffic. It will send to switch should know who is that host and where is that interface connected. So the switch will multicast, and the VLC player will stream that video file for the person, whoever is there. Okay, so these are all the components in the multicast domain. It's totally out of your normal behavior of unicast and broadcast features. Okay, so multicast happen parallelly. So now in the next slide we will see about IGMP and a little bit on this. Okay, So as I told, this consists of three variant: V1, V2 and V3. Okay. So what is IGMP? Internet Group Management Protocol. We don't prefer V1 because of its weaker security concerns. Okay, so this has been out. So let's talk about IGMP V2 first. Okay, so how does this work? So basically, how where do we see IGMP is? Okay, so we see this in router. So basically, router should know which is the host that's requesting those traffic delivery, right? So let's say I have a switch in between. So we enable IGMP so that my router knows that it's a H1 host who had requested it. So there are concepts like join, leave, okay, uh, MRT and querier, whoever is generating the query. Okay, what is join? Join is that particular stage where host has to join this router's multicast domain. So we will configure IP address like 192.168 something, which is a normal class C IP address. But on top of this, we are also gonna make use of multicast IP. Okay, let's say router where we have the IGMP running on this. Now these hosts have to join this 239 series IP. So let's say this has to join 239. Now let's say I have another host, so it has to join that 239 series IP, and that's how IGMP will know whom to send and whom not to send. So whoever is joined the multicast domain will be receiving or will be getting delivered the traffic. Okay, so join and leave. So these are when leave is when you just wanna take the host 3. Let's say I have host 3 out of this domain. He doesn't need any further video streaming, so we can take it out. Okay, what is MRT? MRT is a field in the query packet. So let's say when I have uh, query packets going across from this, okay, so I set a component for MRT within that. So this is the query packet and I set a MRT. So basically this is acting as a time to respond kind of feature. Okay, so if a router is sending a multicast traffic to host, now host might be dead, we never know, right? So what R1 is going to do is it's going to keep a empty space for a timer. It's gonna set some timer there. It's gonna say I need the response from host machine saying that it has received the multicast packet within this timer 10 seconds. So if there is no response, then that will be taken out of that group. Okay, so this is something like a time to respond, or I can say MRT is maximum response timer. Okay, a healthy relation between the routers and the host, so that even if host is dead, router don't spend its bandwidth to respond to the host, right? So that's MRT. Now what is querier? Querier is that router in the same segment which in which one of them is gonna respond to the query messages. I told about the option where we would have two routers, right? Now let's say if this was a scenario, now we have the IGMP enabled. Now which router is gonna respond and which router is gonna deliver those content? I told you there will be election happening and one with the lower IP address will win the election, right? So querier election process is that process where if there are two routers in the same segment, one will be elected as a responder, and let's say if this wins the election, so he will be the person who will respond to all the query packet. Okay, query packet generated here in the case of join and leave. So this is a process, querier is a process to make sure that one router is always active and responding uh, to the query packet. Okay, so let me show you this protocol in action. Okay, so I'll open up this lab. Okay, I guess it's taking time. Let's see if I can put some instant router on this lab and I can show you something. Okay, workbook however will be from our main topology itself. Okay, I'm not gonna take or use something complex topology or something, just so that we don't and spend a lot of time here. What I do is I'll take one router 7200. Okay, I'll make three instances of this so that I have the two routers acting as my host machines, and in the center I'll keep one switch. Let's go with the L2 switch. Okay, something like this. Let's connect them. So this is enough to see the multicast in action. Let's power them all on. Okay, let's go with the console. So let's put some IP address here. Let's say they are 192.168.1.98/24 series. Okay, so I'll take 98 here, and I'll consider like 99 over here and 100 over here. So something like this. And same time, I also need the multicast address, right? So let's keep a multicast 2391.1.1. Okay, so this will act as my multicast responder on the router. Okay, so the first router is been loaded up. Let's rename this. Let's say router 1. Router 1. Let's configure its interface. Let's say its IP address 192.168 30 sorry 1.98.255.255.255.0, no shutdown. Okay, the same thing goes on the host machines. Since I'm making use of a router to demonstrate, I'll better name it as host 1 and host 2. So let's say it's host 1 and this becomes the host 2. Okay, switch will just act as a layer 2, nothing else. Okay, we don't want to configure anything here. No VLANs, no IP address, just for broadcast features. Okay, fine. So once we are on router 1, since we have enabled the IP address, it's time to enable the multicast on the IP address. Okay, but remember, your multicast routing has a special command to enable the multicast packet. Okay, so the command is IP multicast routing. So this can be an interview question as well, because if someone asks you if multicast has been configured but I see multicast routing is not being enabled, so what is that command to enable multicast? So this is a command which enables multicast. Okay, now let's go to interface fa0/0. I say IP address. I have already configured IP address. So let's go and configure the protocols. Okay, so I'm going to say IP PIM sparse mode. Okay, no shutdown, and let's come out of this. So you can see here it says that DR has been selected. Since I only have one router, so this takes up the role of master. Okay, there's no other router, so that there is a election or something. So this has taken up the role of master, and he's gonna be that query router who is gonna respond to all the queries. Okay, so how do I see the status of multicast? The command is show IP IGMP interface fa0/0. So if you see this, so IGMP is enabled on the interface, multicast routing is enabled on the interface. IGMP activity, you can see there is one join. Okay, one join in the sense this particular router is considered as one join. The current version is 2. By default, IGMP version 2 is been taken up, and we are doing a lab for IGMP version 2 now. Okay, so I'll show you version 3 also. And what else do we see? The query interval here is every 60 seconds. Okay, now let's go to the host and as well as this router, and let's enable the debugs. Okay, so the moment I enable debugs, let's see what is seen. Debug IP IGMP, debug IP IGMP. Okay, so it's every 60 seconds the query packets will be sent. Okay, and there you go. So you see a IGMP version 2 packet was being sent from fast Ethernet 0/0. There was some delay timer 5 seconds for .40. Okay, so this is the multicast IP that it has been taken up, considered 224.01.40. Updating the exclude group timer. Okay, there is a MRT. MRT is that particular field which is set in the IGMP traffic, where it says about the timers that I need the response coming from my host machines. Okay, fine. So let's go and configure these host machines now. Okay, so I go to the host machine. Let's go to the interface f0/0 and let's join this group. Okay, okay, so it says that insert group 239.1.1 successful, no shut. So do you see this? Received group record for group. So the same way we can also, okay, so let me also do something here. So we get a membership query general. We have a query packet. We have a group. Okay, so under over here, we can see it's a version 2, the multicast address. So this is a process of IGMP. So I told you there are a couple of things that happens in IGMP version 2. The first thing is it's joining. There is a group message. It features about the leave in case if we wanna drop from that group, we are no longer interested to receive something, so we can just come out of it. And the query election process. Okay, so this is between two routers. The rest is between the host and the router. Okay, so this is a general overview from IGMP version 2 point of view, but there is a drawback of this, that is there is no host formation with respect to source filtering. I mean to say, if I have a router and if a router is connected to a switch, so basically in IGMP version 2, if they are all part of the multicast group, so all can receive the multicast data, right? What if we enable something called as source inspection? So over on the router, I say that this is a source 1.1.1. So I am going to add that source to be 1.1.1.1, and if I receive something from this source, then it's a eligible traffic. But if I receive something out of 1.1.1 like .2 or .3, then I'm not gonna send the multicast traffic to those hosts. Okay, this is from security point of view, because if the traffic would have been shared between all the hosts who participate on that multicast group to 2390.0.1 or whatever the multicast IP was being created for this group. Now, what could be the possibility? Let's say if there was a man in middle, okay, and he's aware of the fact that we are making use of version 2, so he can also join our group and he can also be part of the data stream, because he will be also be sent the data traffic. He can also initiate some attacks here, right? So we don't go with version 2, okay, because version 2 doesn't have any sorts of source checking. So in the case of IGMP version 3, we can enable source filtering as well. So only those source will be allowed to participate in the group, whichever has been allowed. Okay, so let's check that out. Okay, so let's say, so since I've already configured this, I've since already configured this, I just have to increase the version number. That's all. I don't have to do anything else here. So I'll just say IP IGMP version 3. That's all. See, you can see here it started showing for any sources. So basically now it started considering sources. The moment I so what happened as soon as I enabled the version, so the version 3 packet started up. So we can see the query packet from the version 3. Okay, so all the steps happen as similar as version 2, but here there is something for source address also. Okay, so how do we join the group from host point of view? If I'm on interface fa0/0, okay, if I'm over here, I'm gonna add the source now. I'm gonna say IP IGMP. I'm going to join this group 239.1.1.1, and if I do a question mark, there is something called as include source. Okay, so what is the source now? Source is IP address. So I'm going to say 1.1.1 is my source address, which I want to join now. So you can see here it was version 2, but now they are on version 3. These are all version 3 packets. So they perform the same thing. They behave on same similar way, but that's the difference is on version 2 there is no source check, but in the case of version 3, the source will be checked upon. Okay, so this is a multicast configuration from the network point of view. where we have to join the host to a router, and if the packet has to be delivered to the routers. Okay, so the last topic in multicast is the protocol independent multicast. Okay, so where do we use PIM? So PIM is used when we when there's requirement for election, when there are four routers, and let's say the host is connected on this end, right? So router 1 is confused whether to send the traffic on this or on this, right? So what happens now is we go with PIM, which is gonna do the election. It's gonna say that let's go over on this side. So basically this act as the querier. Okay, now depending upon the number of devices that you use in enterprise, there can be two different modes here. One is called dense, the other one is the sparse mode. Okay, so as the name suggests, dense, we use this mode whenever there are lot of uh, host in the network, or in the subnet, who are expected to receive the multicast traffic. So if I have multiple host machines, okay, so whenever I have lot of host machines kept in the enterprise, we go with the dense traffic. So what dense traffic does is it will just flood the traffic everywhere. So it's gonna not here on the host machines. So this is what happens in the dense traffic. Okay, but the issue is, if let's say the host here, he just have left the group, okay, and he don't need the traffic, he don't need multicast traffic now, but since we are making use of dense traffic, okay, now what I do is I'll set up some pruning messages. So with the help of pruning messages, I can stop sending my multicast traffic onto those hosts. Okay, so we can include the pruning in function with along with dense, so that we can say that don't send the traffic to this because they have left the group. And how do we leave a group in case of multicast? So if I go back to this, okay, let's say from my host point of view, if I just wanna leave a group, I just add no in front of this. Okay, the moment I do a no, there will be, you can see it's deleting the packet, right? So this will be called as left the group. It's leaving that group, and this will be not forwarded with any kind of multicast traffic in future. So the dense mode in backend supports multiple protocol. So we have three protocol, but the major one is this, which is PIM. Okay, the first one here is DVMRP MOSPF. Okay, so this is multicast OSPF, and we have distance vector multicast routing protocol. Distance vector multicast routing protocol. We don't use these two, but we make use of PIM in the case of dense mode. Okay, the last mode here in the case of the routing protocol we have is sparse mode. And sparse mode is that scenario when the multicast has to be delivered to very less number of devices or less number of host machines. Okay, so let's say if I have a similar design video streaming, I have a router and router is sending the multicast to host 1 and host 2. So in the case of sparse mode, the request must come from the host, then only the router is gonna deliver the multicast traffic. Okay, if there's no request, then there is no unnecessary traffic sending. Okay, whereas in the case of dense, what the router would have done is it would have flooded. Okay, it would have flooded to every host that is participating in the multicast grouping. So this would have been in the dense mode. But in the sparse mode, it's when the router sends a request traffic. Okay. So when the router receives the request from host 1 and host 2, now that request will be taken care by the protocol. Okay. So in the case of sparse mode, it's when router will request it, whereas in the dense mode, it is until the router has been asked to stop by that no command. If I make no command, then that's how in the dense mode we are going to stop. But in the case of sparse mode, it's not gonna send by default, but it will be sent only when the host is requesting for. Okay, so that ends this topic, a small topic. As I told you, it consists of lot of components and lot of other things. The topic basically is PIM and version 2 and version 3 and little bit on protocol. So there was no lab, but we just did a lab to see how this works in action. Okay, 3.4.d. It's from the Encore topic. There's no multicast in the NRC. All right, so let me know if you guys have any doubts, and we'll take it further from there. All right, guys, I guess it's all good from you. Let me see if there's any chat put up. Okay, fine. All right, so let's meet up in the next class. I'll pass on this class notes recording and the lab as well, so you guys can practice and you can capture it on Wireshark and you can see how the multicast packet has been analyzed. Okay, so have a nice day, and we shall meet in the next class. Okay, so that's all from my end. Take care, everyone.